Hi there, and welcome to the presentation for Group 3. We are focusing on the detection and counting of Baobab trees using remote sensing and machine learning in the northern parts of Limpopo. This project started out with more than just the Baobab tree, but it's since been narrowed down because the Baobab tree is quite unique and is easily to distinguish for validation purposes later on in the project. When we consider nature conservation, there's a lot of work that goes into identifying which key elements need to be protected. Economic expansion is generally the thing that threatens this, and there's a lot of incentive for that expansion. So there is a bit of an imbalance between the parties that want to expand and the parties that would like to conserve. This project is focused on trying to get a bit of that power back to the conservationists with the help of machine learning and remote sensing data. For this project, we were given access to satellite data and aerial footage. Satellite data has got a lot more information, was a lot more dense in its information, as it captures more than just the visible light spectrum, where aerial footage is generally a camera mounted to a plane and can only capture visible light. For this project, we have chosen aerial footage rather, because it allowed us to actually validate visually some of the trees or results that the models have outputted. One of the features of satellite imagery is, however, that you can actually do more complex analysis on the image bands, as shown on the left-hand side with an NDVI index. The approach and method for this is to generate training sets, split them into 70-30 train and test sets, and then run various models and see how they perform on this data sets. We will then compare the performance of the various models. At first glance, the ResNet and AlexNet models seem to be working better, but they perform very poorly when we actually give it real life data, not just the training set. What we have done is we've got two sites, which is site 1 and site 2, to train with. We have then trained all these models for site 1 and validated their performance with site 2. With that scenario, the YOLO model performed a lot better, even though its accuracy and precision numbers reported on the training set seemed to be lower. The validation step was done with trees next to the road, where we could actually utilize Google Street Map to visually see that it is Baobab trees. On the left hand side, you can see the red boxes are the trees that the model identified. Green is where it identified it correctly, and blue is where it missed trees that we could actually see from the road or Baobab trees. This project is a first step in the attempt to use remote sensing data and machine learning to help nature conservation efforts. This approach seems to be promising, as the YOLO model performed quite well with the different scenarios that it was used in. Suggestion for future work is to enlarge the data set of trees and also to gather the data across different seasons and different years, make the model a lot more stable and less sensitive to the input information given to it, to actually be able to identify trees in various scenarios, as well as trying out the satellite data again once a more accurate GPS set of tree locations have been created. Thank you for attending. I would like to now pass this over to my teammate Neacail, who's going to take you through the application.
Thank you, Josh. What you are looking at over here is our Streamlit app, which we use to package our solution. It basically takes aerial images in and generates a data set of GPS coordinates of where the trees were detected. So the first step you're going to do is you're going to upload your aerial images. You can then scroll between your images, applying object detection, and you can also adjust the threshold that you want to have applied to your model. So for this illustration, I'm going to just put the threshold on 0, which means it'll accept all possible locations where trees were detected. Once you're happy with the threshold, you can then analyze all photos. It shows you a summary. So it found 9 trees. This was a distribution of the confidences of the extraction. And then the final step is to just extract that into a CSV. Here you can see longitude and latitude, and then the file name from which they came. So if we look at this tree over here, that was detected with a 74% confidence. It's this first entry over here. We copy those coordinates on. You can see we zoom in to a map that looks very similar to our original aerial image. And there you can see there's the Baobab tree. Thank you very much.